Hello, everybody. Charles from GMAT Ninja. Welcome to episode 2 in our GMAT Clarity series, Ask Me Anything, AMA, FAQ. Episode 2 here, we're going to talk about quant-based data insights, graphs, tables, charts, two-part analysis, multi-source reasoning, anything that has math in it, we're going to talk about today. Can't solve all of your data insights math-based problems in an hour, but I'm going to do my very, very best. As always, this is live, so I have absolutely no idea what's about to come out of my mouth. If you are watching this live, please give us all the feedback you can. Chatter with us. I keep a close eye on the chat. Any questions you have, I will do my best to answer. So I've teed up a lot of examples today. I've also got a lot of general topics, mostly around time management for data insights, because that is, for most people, by far the biggest demon of data insights isn't so much that it's difficult. It can be difficult, but it's more that it's really, really hard to get through all 20 questions on time. So that's going to kind of be a through line through everything we talk about today, all of the different question types, styles, quant-based things, how to get more efficient, more effective. So again, if you're watching live and you have questions, please let us know in the chat and we will adapt to that. I've got about 8 examples teed up. No way we get to all of them, but I will try. I'm going to start with some of the questions that we got. I spent a whole lot of time going through the forum, had some great posts from a few folks. Thank you for that. Had some folks at GMAT Club compile some questions, had dozens and dozens of questions. We kind of distilled down into the ones that are the most common, that are the ones that are the most consequential for the most test takers. And to be honest with you guys, it kind of all boils down to one thing. All those dozens and dozens of questions, like how the heck does anybody finish data insights on time? And even as we kind of focus in specifically on quant data insights today, yeah, that's the big thing that kind of runs through it for everybody. Now, with that in mind, what are kind of the subparts? So for the quant-based, and again, we're going to have another session. This is session number 2 of 7. You want to know about the rest of the sessions, check out the link in the video description. Next week's session, we're going to focus on non-quant-based. So it'll be all of kind of the reasoning, verbal-based, just quant today, but it's kind of same thing. How do you get more efficient? How do you get more effective? So how should you manage your time? Why are these graphs so darn weird? We'll get into some of the bizarre ones and kind of help you with your mindset on those. Misinterpretations of graphs, what drives that? How do you avoid it? How can you get faster and better at calculations? And we'll kind of hone in on some two-part analysis in particular today, time permitting. I had a couple people ask, hey, why am I worse at data sufficiency than problem solving, even when it is quant-based? One really key tip there if we have time. And then multi-source reasoning. We'll finish up with that. I'm not going to torture you with a multi-source reasoning on the screen because that's pretty brutal, but I'll kind of give you some general tips and kind of tie it into everything else we're talking about. All right. Before we start jumping in more detail, and we're going to start with the time management bit. If you're watching this live, especially if you're watching this live or in the first week or so, there is a competition about to start off. It is the GMAT Club Christmas competition. There it is. I'm not sure which way I'm pointing. 12 days of Christmas, GMAT competition. This is team-based, so you answer questions, write explanations on the forum. You are with your team. The winning team gets prizes. There's some really good ones in there. GMAT courses, admissions consulting packages, free GMAT Club test, $30,000 in prizes. You don't have to pay anything. Just show up in the forum, do stuff, answer stuff, learn stuff, help your teammates, help people reading your explanations. That's it. So that kicks off in a couple days here. If you want more information, link right there, link in the video description as well. All right. Back to our questions. How do we manage time on data insights? And is that why my score is so low for those of you who kind of go, well, wait, I'm really struggling here. So general thoughts on time management, general thoughts on data insights and scoring. So very, very few people can comfortably get through the 20 data insights questions in 45 minutes. Quick little bit of history. The predecessor to data insights was a thing called integrated reasoning. For about, I don't know, 10, 12 years, it was this weird little 12-question appendage to the GMAT that wasn't part of your composite score. It was just kind of there, separate little subscore. And it was brutally time pressured. And it was 12 questions, 30 minutes. And here's the thing that we found, like it wasn't important really in admissions back then, but what we would say to candidates is, look, there's no way you're getting through 12 questions in 30 minutes comfortably. It's not going to happen unless you're a real freak of nature, in which case you're probably not watching this video. So your job is to pick your battles. And of those 12 questions on the old version of this, I want you to do 8 or 9 really carefully. And the 2 or 3 or 4 that are looking at you funny and you go, I don't even know where to start this thing. Just take a guess, wave bye-bye, let it go. Pick your battles. If you start flailing on something, walk away. So part of your process should be read the question, get the lay of the land in terms of the data display, figure out broadly what's going on, take a look at the question, Don't grip too hard on the information given, and we'll practice that a little bit in the examples today. But whatever you do, as soon as you kind of start getting engaged in the question, if you go, I have no clue what's going on, you're 30 seconds in, 45 seconds in, let it go. And the funny thing was, once we started giving people that advice, back when the predecessor to Data Insights didn't really matter for admissions, their scores went up. We started seeing perfect scores all over the place because people would do 8, 9, 10 questions really, really well, really carefully, guess on the rest, and they'd get fantastic scores. So when they created Data Insights back in 2023, they took the old integrated reasoning section, they added data sufficiency to it, tweaked a couple things, made it longer. But here's the key. They intentionally, deliberately in the design, and I've spoken to the psychometricians quite a bit, the people who designed the test, they kept the time pressure intact. They said, hey, we don't want to change that part of it. And then they kind of realized a year or two later, and they've shown us some of this data that, yeah, it's really time pressured for most people. Very, very long-winded way of saying two things. Number one, the time pressure is normal. You should feel pain on Data Insights. If you don't, good for you, but most of you will. That's normal. Embrace it. Second, bail when you flail. You start to struggle on a question, don't know what to do with it, walk away. Now, with that in mind, we're going to spend a lot of time today on ways to become more efficient. But when there's something and you look at it and go, whoa, my head's spinning, I don't know what's going on. Don't get sucked in for 4 minutes, 6 minutes, 8 minutes. Let it go, walk away, pick your battles. 20 questions, 45 minutes. Depending on where you stand, you might be doing 16, 17, 18 really carefully and guessing on the rest. Make sure you control the test, which ones you guess on. The ones that are looking at you funny, let them go. Invest your time in the ones that are easier for you. All right. One last thought on Data Insights. Most of the students we hear from, in our private tutoring students, vast majority walk in and say, I need more work on my Data Insights score than anything else. That is becoming increasingly common. Part of that is on the current scale for the GMAT. Kind of there's a sense that you need to get an 80 on all three sections to be competitive. And I think kind of psychologically for admissions people, 80, 80, 80 across the board, that's pretty strong. Again, it's going to depend on a lot of things where you're applying all of that. But here's the thing. The average scores are different. Quant, verbal, Data Insights. Verbal, 79. Quant, 78. Data Insights, 75. So sometimes we see people who go, wow, I'm really awful at Data Insights. It's 4 points lower than my verbal. That's actually normal. So it's a bizarre little quirk of the test. Sometimes people freak out about their Data Insights score being lower. And it could be the case that your percentile is really strong, even if you don't love that raw number. So just keep that in mind as you're interpreting your score, figuring out where to invest your energy as you study. All right. With that, let's see. Let's get into question 2. Why are these graphs so freaking weird? A lot of the comments we get is, what is this? I stare my eyes out at these things. So I want to hone in a little bit on some of the funkier looking graphs. What do I mean? Boy, GMAT's getting creative with this stuff, for better or worse. And I would make the argument that all of these 4 graphs are as clear as mud. Upper left corner, pie chart. This is ugly. This is really hard to interpret. This is not something you look at and go, wow, I understand exactly what this is trying to say. You really got to kind of grind through it. There's lines sticking out everywhere. Looks like a bicycle wheel. What are we doing? The one right below it, it's graphs that kind of go inside other graphs. It's really bizarre. Upper right corner, you've got 2 different colored dots that mean 2 different things. Plus you have 2 axes, 2 vertical axes and a horizontal axis. 3 axes, 2 different colors of dots. This is not healthy ways to produce graphs. But this is kind of the real world. I think a lot of you have probably been in job situations where somebody says, hey, I'm going to communicate some data to the team, and it is ugly. It is sometimes really ugly, really confusing. And GMAT's kind of representing that in some of these. And the key is be calm. There's a story here. And the first thing I want you to do whenever you see a graph, a chart, a table, whether it's multi-source reasoning, table analysis, graphical interpretation, is just go, hey, can I tell the broad story? That's it. Don't judge whether it's a good graph, that one on the bottom right. Are we really sticking a line graph and a bar graph in the same thing with 2 axes? That's kind of ridiculous. It's ugly. But your job is just to say, hey, don't grip too hard on the details at first. Can you tell the story? All right, with that, let's tackle that one that was in the bottom right corner. This is one of my favorite examples of, I'll be honest, first time I looked at it, my first thought was, this is ridiculous. This is, who does this? But it's really not that bad. So go ahead and take a couple minutes on this one. If you are watching live, please, as soon as you have a reaction or an answer to these two questions, pop it into the chat. That's what we feed on here. The more feedback you're giving me, the better I can make this for you and for other viewers. So please chatter at me. I'm not seeing a lot in here yet. But please let me know what you're thinking. And as soon as you get an answer, please toss it in the chat. Oops. All right. If you're watching live, please keep the thoughts and comments coming. If you're getting answers, keep popping them in. Those are super helpful. You guys are quiet today, so please chatter. Nobody's going to judge. If you're not chattering, I'll judge. How about that? No, that's not nice. Okay. Excuse me. Again, what I do judge is I think this is a really unpleasant, ugly graph. I think this is a bad way to display information. Yeah, that's kind of the point. That's what we're doing. So what's the key to getting better at this? Some of it is psychological. Some of it is just saying, yeah, they're going to be a little bit weird. Now, what I want you to do, don't grip too hard in the beginning. Don't obsess over every little piece of information. I just want you to think, can I get this story? Read the text. Pretty straightforward here. This is one that doesn't have a ton to it. It's just describing what's in there. You've got the lines. What are the lines? Red line is a tax on company A over the course of this 11, 12-year period. Blue line, a tax on company B. Okay, A's went up and then they kind of plummeted later. B's kind of bounced around more, and then they kind of more or less the trend line is they're going down. Great. What are the bars? The bars are their spending. So they didn't spend anything until looks like 2006. B starts spending first, A starts spending later. Okay, cool. So these guys start getting cyber attacked more and more for company A, and then they start spending, and A was really slow to the party. Okay, good enough. You understand that broad story? Can you explain it to somebody in a sentence or two? That's all you need. One of the places where time goes to die on Data Insights is just digging in and staring at every little detail. Don't do that. Not yet. Once you understand broadly, here's the kind of information, here's why they've piled bars and lines on the same chart. You get that? You're good. Now go on to the questions. And only then do you really want to hone in on every little detail. Okay, question number one. From 2000 to 2011, the number of successful cyber attacks that A experienced was blank, the number of successful attacks that B experienced. Okay, so really you're just trying to count using those lines. We're talking about the number of attacks. So in that first 4-year period, 5-year period from 2000 to 2004, B is getting attacked more. After that, for a little while, A is getting attacked more, and then they kind of the last couple of years they're in tandem. So again, theme today, how do you get not just better, but more efficient? What I see a lot of people doing on this question is they sit there and go, well, okay, I'm going to take the blue, and so okay, that's company B, and we've got 8, and then we've got 3 on the next one, and then we've got 5 on the next one, and they try to add up. Well, there's 12 numbers. What are we doing? You're going to get 12 numbers for B and 12 numbers for A. So whenever you feel yourself doing something like that, where it's like, I'm going to go add up 12 numbers for each just for one of the 2 questions here, that's ridiculous. Whenever you find yourself doing something like that, stop and go, hey, there's got to be a better way. That's how these questions are designed. They reward efficiency. They reward the ability to step back and go, maybe I can do something better. Maybe I can do something better. Don't do that. Can I eyeball the graph and come to a conclusion here? Not quite. Maybe, but not quite here. Because you've got, again, B is higher than A first few years. Then there's a period where A is higher than B. You just got to figure out which one of those kind of gaps is bigger. So personally, I wouldn't feel totally safe just eyeballing it. It looks to me like that period from about 2005 to 2010, where A is getting attacked a lot more than B. Boy, that difference between A and B looks a lot bigger than the difference between A and B at the beginning of the period from 2000 to 2004. I wouldn't quite trust that. I'd probably count a little bit and say, okay, 2000, B had 8 more attacks. 2001, B had, looks like 2 more attacks. 2002, 2 more attacks, 3 more attacks, something like that. They were the same in 2003, 2004. You get about 4 more attacks. Add that up. What do you get? I don't know, 15, 18, somewhere in there. And then you come over to the period 2006 to 2010, where A is getting attacked a lot more often, and that gap is huge in some cases. So 2006, you've got a gap of about 4. 2007 looks like you've got a gap of, oh, what is that? I don't know, 5 or 6. 2008, the gaps, again, looks like about 6. So A is definitely getting attacked more. So our answer for that first one is going to be A. A's attacks are greater than. So again, the key here, it's the flexibility to say, I don't want to just add up a big fat pile of numbers. Can I eyeball it? Can I find a shortcut? Can I do something that's quicker? All right. So A is your answer for number 1. Number 2, only year where increased spending coincided with a decrease for both companies was which? And again, what I saw just now from the live audience, I see a lot of correct answers. I see some wrong answers. But what I do notice is the people who did this a little too quickly were more likely to miss it. That's pretty common. And I saw a big lag, a lot of time spent. And that's what we see in the stats on GMAT Club as well. Okay, so if you're going to look at every single year, you're going to get tortured. Think about what you're looking for here. Only year in which increased spending, so bars going up, coincided with a decrease in the attacks for both companies. So we want a year when spending's going up. So we're only interested in the period from really 2008 onward, because A doesn't even start spending until 2008. So it's only 2008 onward, which is reflected in the answer choices. So B goes down from 2008 to 2009. Can't be that. I'm sorry. I had that wrong. Yeah, so A is flat for a while there. So the attacks are going up. When did the attacks start going down for A? Just those last years, 2010, 2011. 2010, it's going up for B. It's only from 2010 to 2011. That's the only time when the attacks are going down for both companies. That's it. So as long as you're enterprising about focusing on the right area of the graph, it's just where the bars are going up at the end. It's just when the two lines are moving in tandem downward. It's just that last little period, 2011. That's it, and your answer is D. Okay. That was your warm-up, guys. I'm going to come back here full screen for a second. Oopsie. Okay. So weird graphs. What's the punchline here? Big punchline is find the broad story first. Don't get sucked into the details. The broad story is always there, number 1. Number 2, embrace the psychology. Some of these are weird. That's normal. That's how this is designed. Get used to it. All right. I think that's enough of the weird graphs. There are specific kinds of graphs. We see plenty of people struggling on it. Again, if you're watching this live and there's certain things that bug you, let us know, because I teed up some extra questions. If you happen to hit on something that I've got ready, happy to swerve off script a little bit here. So misinterpreting graphs and tables, especially when there's correlation, trend lines cause problems, shifts in units cause problems, things like shifts from percentages to numbers. Now, we could easily spend probably an hour-long session on just this one question of, hey, why do I misinterpret graphs? What are the things that cause that? I've got a whole list of those, got a whole bunch of favorite examples. Can't do all of them because we've got other things to cover. Probably spend 3 or 4 hours on just this. I want to start with correlation, because that is something that I see lots and lots and lots of issues with. I think if I were to ask all of you, hey, what is correlation? What does that mean? And most people, even if you don't have a heavy stats background, most of you will say something like, oh, well, correlation means that as one thing goes up, the other thing goes up. So maybe it's a pretty little graph that, kind of looks like this. And maybe there's a trend line going through it. Positive correlation. As one thing goes up, in general, the other thing goes up. Negative correlation would be the other way around, obviously. So as one thing goes down, the other one goes up. Okay, fine. That's the general definition. Most people know that. As one thing is going up, in general, the other one goes up. Positive correlation. Negative, they're going in opposite directions. That said, I see annihilation when I look at how people perform on questions that actually involve correlation. So I'm going to give you one and see what you guys do, and then we'll talk about kind of the big pitfall in here. I think you all probably know the definition and are comfortable, but I think I'm going to see some damage on this because I've seen a lot of damage on this one before. All right, go ahead and take a minute or two. I've cut off one of the questions here from this just in the interest of time. So table analysis, I sorted the table for you, and I'm just interested in what you do with these first 2 questions. Go ahead and take a moment if you're watching live. As always, would love, love, love to hear from you. Let me know what you think. Perfect. Everybody watching live, thank you for all this, because I'm loving what I'm seeing from the group. Okay, this is perfect. So I'm seeing everybody kind of dividing down the center on the second question here. First question, pretty straightforward. I left it on there probably for no good reason, because I think everyone gets this. Every store whose average customer age falls between 34 and 36, that's just 2 of them. We've sorted by age here, so just A and F. Yeah, you can see that they're above average for the self-check unlimited lanes, or sorry, self-check express lanes. Easy enough. So true for the first one. Very, very straightforward there. True for the first one. It's the second one that's really fun. because what does correlation mean? I don't want you to confuse these two things. I'm going to draw, let me go back to half screen here. I'm going to draw a stupid little picture for you guys again. So when I say, hey, here's a couple of variables, and you'd say, yeah, these are positively correlated. As one goes up in general, the other one goes up, right? Straightforward. Most of you see this kind of thing in daily life and go, yep, positively related. Whatever this might be, this is maybe, I don't know, years of education, and this is salary. I don't know. More education, more salary. Yeah, on average, you bet. On average, positively correlated. More education is going to lead you to more income, on average. Does that mean that it's true for every single person or every single country or whatever these dots might be? No, it's not going to be the case for every single one. It's not going to be a perfect relationship. Don't confuse correlation, which means a general trend, and complete proportionality or a completely linear correlation. This would be a linear relationship where for every year of education, everybody gets paid exactly the same amount more. That's more than a correlation. That is perfect proportionality, direct proportionality, or a linear relationship. That's not what you have with correlation. It just means a general trend. Okay, coming back to this beautiful table. What is the general trend between self-check unlimited lanes and average customer age in these stores? So again, we sorted by average customer age, far right of the chart. So average age is going up as you read downward. What happens to the number of self-check unlimited lanes? Well, there's a lot more self-check unlimited lanes in all of the stores that have that are above average for customer age, or sorry, below average for customer age. Top half of the chart, above that average. So you've got 6, 8, 4, 4, 6. Those are at the stores where people are younger on average. And then you've got 4 below that, old customers toward the bottom of the table. In those, you've mostly got no self-check unlimited lanes. You've got one that has 4. Is it a perfect one-to-one relationship between age and self-check unlimited lanes? No, it's not a perfect relationship. But in general, is it the case that as you have older customers, there are fewer self-check unlimited lanes? Yeah, you bet. When the average customer age is above average, the number of self-check unlimited lanes, typically 3 stores out of 4, is going to be below average, and vice versa. Younger customers, stores with younger customers, more of these self-check unlimited lanes. That, my friends, is a correlation. It's a negative correlation. Don't confuse correlation with perfect relationship. And out of the live group, I saw, I think maybe more than half wrong answers here. And that's typical. So don't confuse correlation with perfect or linear or completely proportionate. The general trend here, older customers, fewer unlimited lanes. Perfect? No. But the answer to this one is absolutely true. Okay. Hope you guys enjoyed that one. I think in the interest of time, where are we? We're about halfway through. I don't think I'm going to go through this one. And you can, if you want to, you can pause. You can go search for this on the forum. There's a great discussion going on over there. But this is really the same thing we just did, except that it's a little bit of a kookier graph. So you've got 2 different dots, 2 different groups. Feels a little bit more complicated. But now it's going to look like this. Is there a correlation? And that's all you're being asked. And the reason people miss this is because they're thinking that correlation must be perfect, and it doesn't. Okay. Yeah, coming back to the last one, because I'm seeing some good questions come into the live group. So holds true for 4 stores, negative correlation. Yeah, so fundamentally here, what is a negative correlation? So positive correlation, things go in the same direction. So as one goes up, the other goes up. As one goes down, the other goes down. So that is a positive correlation. Both are going in the same direction. Negative correlation is one goes up, the other one goes down. So the little picture I had earlier, these red dots, this is your negative correlation. So as you look at this, average customer age up, on average number of self-check unlimited lanes down. So that's a negative correlation. So thank you for that question, because I think some people do get confused by that. As one variable goes up, the other one goes down, that's negative. As both go up, if they're going up in the same direction or down in the same direction, positive correlation. Okay. Back to that pretty graph. So same idea, just graphical version of it. I'll let you guys tackle this on your own. I'm not going to go over it because I got plenty of other things I want to cover. Okay. Next topic. Shift in units. So I keep misinterpreting graphs. We talked about correlation a little bit. Sometimes people get confused by trend lines. Shift in units, weird units. What do you do with that? Lot of different manifestations of this. I'm going to pick on one or two here. And really kind of the heart of this is what I see people doing. What is the behavior that induces you to miss something because of units on a graph? Where does that come from? Where it typically comes from is you're just kind of rushing through and kind of looking at something a little bit superficially. So I'm going to go ahead and blow this one up a little bit. I'm going to give you guys a couple minutes on this. I'm going to help you along a little bit by just saying the axes aren't what they feel like they should be necessarily. And maybe you look at this and you have a certain kind of math or data background and you go, I can define what this scale is. I've got a name for it. It's a logarithmic scale, whatever. Maybe you can do that. If you can, it shouldn't matter. You shouldn't need any technical knowledge here. You just need an awareness that, wait a minute, those graphs, those axes are a little bit odd. Let me think logically about what they're doing, and you should be fine. All right, with that, I'm going to shut my trap for 2 minutes and let you guys take a look. All right, live group, thank you. I'm seeing some success on this one, so I won't spend too much time on it. So again, thank you everybody for your participation. Helps me enormously. Okay, maybe these axes, again, some of you have sort of a technical understanding of this kind of graph. You've seen it before as far as like these non-linear axes. You don't need that. You just need the awareness to go, okay, wait a minute, what's the story? Start with that broad story, 20 seconds, 30 seconds before you go crazy on the details. What's going on here? Okay, y-axis, vertical axis, as you go up, more luminosity, brighter, kind of funky. You've got exponents over there. So I guess we're saying that a luminosity of 1 is the same as the sun, but then kind of that next tick mark, 10 squared, that's 100 times brighter than the sun. And the next one is 100 times brighter than that. Okay, so this isn't linear. Fine, that's all you need to understand. Good enough. So blue giants, red supergiants, super, super bright. White dwarfs, main sequence. Some of those main sequence, not so bright, kind of like me. Temperature, what's going on that horizontal axis? Again, not linear, 40,000, 20,000, 10,000, not evenly spaced. Fine, make a note of it. But what are we saying? Yeah, the cooler ones are over there. So red giants up at the top. Red giants are really bright, not very hot. White dwarfs, not very bright, like me, but super, super hot. That was about to turn into a really weird joke. Okay, fine. As long as you get that broad story, you're in good shape. You can tackle the questions. Question number 1, if it is assumed that one of the stars represents the sun, it must be that the sun is a blank star. So again, the sun is what you're kind of indexing to here. So the sun is going to be a luminosity of 1. So the only thing with luminosity of 1 is you kind of look across the chart. It's only main sequence. So number 1, your answer is A. 2, and it's question number 2 that usually people struggle on. I see a little bit of struggles from the live group. Apart from the main sequence stars, which span everything, the group with the stars with the greatest range of temperatures is the group of what? Now you start by eyeballing this, obviously, and you go, well, white dwarfs and red giants, those are about the same width, about the same range of temperature. It looks like. Well, how do you know which one is the right answer? That's when you go to this kind of funky horizontal axis and go, well, as I'm further left on it, that span is bigger. So white dwarfs seem to span from about 15,000 up to close to 40,000. The red giants narrower, 10,000 and below. So white dwarfs are our answer. So answer number 2 is D. So we've got A for 1, D for 2, and that is it. So again, broad story first, get that. Don't dig in too much on the details. Check out your axes. What's going on? They're a little funky. Fine. Do you understand broadly what's going on? Yep, good enough. And that's all you need to do. Don't waste time doing more. All right. Now I'm going to give you one that might melt your faces off. It melts a lot of faces off. I hope I'm wrong. I hope you don't struggle. Another one that's a little bit weird. In this case, it's not that the units, or it's not that the axes are weird. I think some of the information given is a little bit weird, counterintuitive, doesn't necessarily look like what you're really looking at. I'm going to shut my mouth, give you guys a couple minutes. I love it. Live group, keep these coming. For anybody watching live or not live, the first 4 people watching live who offered answers up, they had 4 different answers, which makes me happy. It means we got something tough here that's going to be useful. So keep them coming. Before I get into this question in any real detail, I want to toss a question up here that I think is a really good one. Okay, so you look at a graph and its axis and you can interpret what the graph is saying. Is it necessary to read the context in the question stem? So this is kind of referring to the previous one, but it's a universal question, right? Like, so do you need to read this stuff? I think it's dangerous not to read it at all. I would always read it, look at the graph. I don't really feel strongly about, do you start with the graph? Do you start with the text? What I do feel strongly about is don't grip too hard on the text. Sometimes what happens is you read the text and go, if you start by reading the text, you go, that didn't make any sense to me. Sometimes you really need that picture to make sense of the text. Sometimes you need the text to make sense of the picture. But what you don't want to do is completely ignore the text, because sometimes it will give you some piece of context that totally changes your interpretation of the graph. So I think it's really dangerous not to read it, but don't grip too hard. So use the two in tandem, get the broad story. So don't ignore the text, absolutely don't ignore it, but use it as part of that first step of getting the broad story. What's the story here? This one's funky, which is why I'm seeing a lot of struggles with the live group. And again, thank you so much, everybody, for offering all that up. Okay, so we've got this company, and if we just look at the graph, so let's pretend that we're just looking at the graph. I would look at this and go, okay, we have sales, we have products. It looks like more products, more sales. But what are A, B, C, D, E, and F? What does that mean? Why are these different colors? Why are these different sizes? I need the text to make sense of it. So what is the text telling us? Well, it's telling us that the bubbles correspond. So the size of the circle and the number inside the circle indicates the proportion of customer transactions in that region. So if you kind of look at that and go, what does that really mean? So proportion of interactions in the region. So we've got this region, and we've got whatever this is. We've got 6 different regions, kind of, that this place sells appliances. So these are proportions, and you can kind of take a quick look and go, well, does that add up to 1? Does it add up to 100%? Yeah, it does. So what is this? What are we saying? So if we look at that big purple dot in the middle, C, 0.33, what does that mean? It's saying that 33% of transactions are in region C of the total transactions in the company, so about a third. Okay. Well, if we look right above that, the little guy, E, 0.05, it's saying 5% of transactions are in region E. Okay. So what's the broad story here? More products offered in different regions, more sales. Okay. Bigger circles, more transactions. But it kind of looks like there's not a clear relationship between size of the bubble and sales or number of products offered necessarily. So, okay. Well, with that in mind, what can we do with this? Can we start to make sense out of this? Question number 1, among the 6 regions, the one with the most transactions ranks blank in the number of product types marketed. So which one has the most transactions? Again, that's size of the bubble. That's C, purple guy. That's your most transactions. Where does it rank in terms of the number of product types? That's your vertical axis. That's your y-axis. It's 4th. So F has more products. E has more products. Center of D is up above the center of C. D has more products. So C has the 4th most products. So as written, this question, the answer is D for number 1. Question 2, region for which the value of the average transaction was greatest is which region, A, C, E, or F? This one really caused trouble for you guys, and I think it's interesting. So average transaction is greatest. What does that mean? What's an average transaction? Well, that's the value of the average transaction. So that's going to mean dollar amount per transaction. So what do you want? You want more sales, more dollars, fewer transactions. Okay, so where do we see a bubble that has lots of dollars, but not very many transactions? Well, F has the highest sales, but does it have the highest value per transaction when it has 3 times as many transactions as E right next door to it? So E has a little bit less sales, but 5% of transactions. F has 15% of transactions. And the difference in sales is really, really small. So your answer here is actually going to be E, not F, because E has the highest ratio of sales to transactions. 5% of transactions looks like about 700 in sales. I think it's thousands of euros or whatever. So your answer here for number 2 is E. And very, very few in the live group got that. And I think that's really, really interesting. One more general thing, and we're down to about our last 15 minutes here. So again, guys watching live, if you have general questions, toss them in there, because I've got a whole bunch of stuff teed up. We're not going to get to all of it. And I will make choices based on what you guys want to see. So feel better scanning the graph and reading the question later sometimes. Actually, yeah. Well, it depends on what you mean here. It depends whether you mean question or the text. I am really agnostic about, do you start with the visual or do you start with the text? Sometimes it's going to, for some of you, you're going to feel better reading the text than looking at the graph. Personally, I'm kind of going back and forth, but not gripping too hard to get that broad story. What kind of information do I have? What are the axes communicating? In this case, what are the bubbles communicating? That's the confusing part. I need the text to help me get there. I don't look at the question until I have the broad story. So I wait until I go, okay, I understand what kind of information is here. Then I look at the question. So I wait on the questions until I feel like I have my head around the kind of information presented. Because if I look at the question too soon, then I start kind of hunting at stuff, and that's when you start wasting time. Broad story first, no more than that, then hone in on your questions. Okay, let's see here. That is not what I meant to do. Okay, so I think that's enough on some of these graphs for now. I've got more that I think would be fun to go through, but I want to get out of here in 14 minutes. So again, broad story first, things will look weird, get used to it. Correlation is not necessarily perfect. It's just a general trend. Positive correlation, if things are generally going up on one for one variable, they're generally going up for the other. Negative, as one goes up, the other one goes down in general, on average. That's all correlation is. It's not perfection. As long as you keep those things in mind, it's going to move the needle for you. Question 4 out of 6. How do I get faster and better at calculations and data insights? I've got questions about picking cases. I'm not going to get into that too much. I want to talk generally about calculations and data insights. Why do people go slowly? How do you burn time? What are the habits that lead to too much slowness here? Habit number 1. A lot of you guys forget about the calculators. I would say it's about 10% of data insights questions where the calculator is really helpful. Might not even be that. So every once in a while on a table, that calculator really comes in handy. Once in a great while on data sufficiency, sometimes on two-part analysis, rarely on graphical interpretation. It is really helpful. And a lot of you guys forget about it. Some of you lean on it too hard, but a lot of you forget about it, especially the people who are a little cocky about their quant. I've got a degree in economics. I don't need a calculator. I've got a degree in economics. I think I don't need a calculator. It saves me time on one question out of 10 or 20. So don't forget about it, number 1. Number 2, a lot of the time, this is about pattern recognition, not doing a ton of calculations. So one of the graphs we did earlier, the one with the crazy lines and the bars going up, yeah, you didn't have to calculate every little thing. And part of this is just about your process, your psychology. When you feel yourself tempted to do tons of calculations, stop and go, wait a minute, there's got to be a better way. These questions are designed so that you can do them in 2.5 minutes. If you see the quick way to do it, if all you can think of is a slow way, take a step back and go, is there something better? Is there something better? Fight for that better way. And if you don't find it and the path you're thinking of is going to take you 5 minutes, guess, move on. Remember, you can come back and edit stuff at the end if you have time left. So let stuff go if you're stuck. All that said, a lot of, I've got 2 questions I really want to go through and we're running out of time. A lot of questions, two-part analysis in particular, I think I can point to and go, they love giving you questions that look like really painful math, and they're not. So in some cases, it's you have two-part analysis. You have 2 columns, you have 2 sets of answer choices, and they're kind of dependent on one another. And a lot of the time, if you take that question on two-part analysis, the quant-based ones, and really do everything well, you're going to get a nice, clean relationship. You don't have to pick cases very often if you're really doing the right thing with the question stem. If we had more time, I'd dive into that in massively more detail. As it is, I just want to flash one at you real quick here. I'm going to give you a couple of minutes, and I'll keep this pretty strictly to 2 minutes. I'm going to give you guys a hint. This looks rough. It looks like really hard math. If you're thoughtful about it, you can finish this in, I don't know, after you read it, 30 seconds of work. Going to take a minute or 2. And this is not an easy question, for the record. Okay, live group, keep letting me know what you're thinking, please. Haven't seen anything yet, 2 minutes in. If you're not watching it live, hit the pause button. Grapple with this for a bit. And I think when you see what I have to say about it, you're going to laugh pretty hard. But go ahead and finish it if you are not watching it live. Live folks, apologies. Let's jump back in because we are down to our last, I don't know, 8 minutes or so. Okay. Most people here, you might be thinking, oh, compound interest formula. And I'm going to go do a whole bunch of calculating here and compound interest. And remember that formula. And there's going to be lots of crazy math going on. As soon as you start thinking that, or you start doing a whole bunch of really painful stuff, again, what's the habit of mind I want for quant-based data insights? This is getting really painful. It almost can't be that. It can't be that complicated. And instead, I want you to think, is there a way that I can step back and think about this and get something better? What do I understand here? Okay. So on this guy, so we've got $100. It's invested. It's at a constant interest rate. So that means you're going to compound interest, right? So over time, you're going to make more per year off of this compounded investment. But think about how compound interest works. So if you're making, I don't know, 6% per year, and the reason I'm picking on 6% is that looks like about, oops, this is wrong. Fix that in just a sec here. So this is the start. We've got $100. After 5 years, we've got $130. What did it say? 2 cents, 1 cent, something like that. $130, 1 cent. So what's going on here? So over 5 years, you've made 30% total. So you're making about 6% a year, roughly. Is that exactly right? No, it's not. But that's half the fun. I know roughly what it is. And now I've got a whole bunch of answer choices here. Can I just kind of get a sense of what would be reasonable? Like, I think these would go up every 5-year period, right? So it's $30.01 in gains in that first 5-year period. Well, is it going to be exactly that in the second? Nope, it's going to be more. Is it going to be massively more? Not necessarily, no. So this might be 160 something, but it's got to be a bit more than that, right? And so on. This has got to be, a good bit more than 190, 220. We're going to be, quite a bit more, and so on. And are these exactly right now? No. But let's see if it's good enough. Because if I sit there and torture myself going, well, boy, if I take the fifth root of 1.3001, then I'll get the exact value of R. You can drive yourself crazy here. Don't drive yourself crazy. That's my job. So maybe something like this. This is, again, not quite right. This is too small, right? All of these are too small. But look at the daylight between these answer choices. So it can't be this first. So you've got an answer choice that's 160.02 from here. We know that's not right. How do we know? Well, it's compound interest. It can't be 160 and 2 cents, because that would mean that we've got simple interest and we don't. We've got compound interest. So this is your first error. Now, as you look at the rest of these, so these are going to start going up, but you get some numbers that are totally wildly out of line here. And that's where the magic is on this question, is recognizing that some of these numbers just don't make any sense. And I'm sorry, I'm having a little technical glitch here. Okay. So 219, we've got 285, we've got 317, and we've got 482. So we've kind of got these increments that kind of make some sense. And then you've got this massive jump over here that doesn't make any sense, and that's your second error. Actually, no, I'm sorry, that's not your second error. You got this massive jump here, and you're looking at that and going, hey, there's a huge, huge jump here and a very, very small one here that doesn't seem to fit. Based on that, you know that 317 has to be the error. So I was a little bit, I didn't do a great job here, to be fair, you guys. Like, I was being a little bit too flippant and saying, hey, we're going to keep this pretty close. So it should be increasing by more than I suggested. But if you just look for the discrepancy here in these answer choices and go, I know this is too low. And then as you sort of look at how these are increasing by 60 here, by 65 here, something's wrong with the gap. The gap is not increasing at the right rate. If you kind of squint and look at it and you go, this is the thing that sticks out and really doesn't fit. And it can't be the case that this works, because look at how small this is right here between 285 and 317, how big it is here. So bottom line here, Look for those patterns. And I apologize, this was not my most elegant explanation of the year here. Look for those patterns. And instead of really getting yourself sucked into the exact numbers, just go, hey, can I squint and go, a couple of these things just don't fit. You shouldn't have to do any calculating here. And that is typical. That is a design feature of two-part analysis. They are absolutely writing questions all the time where you are rewarded for stepping back and going, can I spot the broad pattern? Okay, I've got another favorite here. I'm not going to go through it because we need to wrap up in 3 minutes here. But this is one of my favorites because this looks like quant, and I see people picking numbers, picking cases, coming up with stuff and trying to find values here. So feel free if you really want to. If you want to pause, go through this, you're welcome to. Google it. You'll find it on the forum at GMAT Club. The reason I like it so much is it's not that at all. Read, think, and it's not that hard, I swear. And the number of people who miss it, huge. But it's read, think logically, think like a normal human. If you get buried in calculations, you're missing the boat. And again, as soon as you have that sensation, I'm doing tons of calculations, watch your back. You might be doing something you don't need to be doing. Okay, I wish I had more time. I'd go through this one because it is a favorite. All right, 2 last broad questions I want to finish up with. So why am I worse at data sufficiency than problem solving? This almost always, and quant-based data sufficiency, to be clear, there are non-quant-based data sufficiency. We're going to cover that a little bit in episode 3 of the series. So if there's anything you want to see in that, hit us up on the forum. We have an AMA thread. Ask me stuff. We will cover it in the next one. So non-quant-based data insights, episode number 3. Quant-based data sufficiency, why are you worse at it? 100% it's process. 100% it's your process. You're not systematic on data sufficiency. What does that mean? It's really looking at that data sufficiency question stem, doing everything you can with it before you jump into the statements, and then being really disciplined with your process, keeping those statements separate. This is something every time I've done data sufficiency, going back to the beginning of time, 25 plus years of teaching, that's what we really focus on. So we've got videos all over the GMAT Club channel, GMAT Ninja channel that address this. So go find the data sufficiency videos here at GMAT Club that I've done, or over on the GMAT Ninja channel. And I go over exactly what that process is. So if you're great at quant, struggle on data sufficiency, even when it's quant, it's your process. Be disciplined about how you do it. We go through that process in these videos. Oops, we are not going to do this one. That is in one of the other videos. Last question, how can I get faster at multi-source reasoning? Guys, everything I just talked about today, there's a reason I saved this for last. This might be the single most common question I'm asked. Multi-source reasoning kills me. These 3 tabs are awful. This general concept, get the lay of the land, tell the story before you get sucked into every single detail. That's the heart of it on multi-source reasoning. Do you understand the types of information are being presented? Most multi-source reasoning falls into a few categories. It's tables, it's graphs, it's a combination of both. If you're efficient in how you think about tables and graphs, you get the lay of the land, you don't get sucked into the details, you bail when you flail. If you do that on multi-source reasoning, yes, it's intimidating, but you will get a lot better and a lot faster, I promise. They are not fundamentally more time pressured than graphs, tables, or 2-part analysis. So multi-source reasoning, if you're struggling, it is the same skills that we're talking about with everything else. And I promise if you get your mind right and don't let yourself get sucked in, you will get more efficient, you will get better, and you will get more comfortable. All right, that is it. We're at the end of our time. If you enjoyed it, please smash the like button. Please subscribe, all the good things. And if you have questions, check the link in the forum or link in the description. Come see us on the forum. Ask me anything and we will cover it. We've got 5 more left in this series. Verbal and logic-based data insights coming up next week. All right, that's it for today. Thank you so much for watching, everybody. Thank you for the live group for the participation, and have fun studying.